Hello friends, this is our operating system class. In previous class we have learned analysis of algorithm. We analyze the different types of CPU scheduling algorithm. And now here we will learn multithreading. What is a multithreading? Multithreading is a process in which we divide a process into its multiple lightweight components. Means that from a single process we create multiple lightweight processes, or we create a component from the process. Means that if we have a process P1, then we will have to create multiple lightweight small processes of P1 having some common shared section like a code section, data section, and file section. As you know, there is a main memory. In main memory there is a process P1 process having different section like it's a code section, it's a data section, it's file section, it's a stack, heap, and different types of sections are available. In single process there are 4 or 5 sections are having. In the same manner, if there is another process P2, then have same things. There are code section, data section, file, heap, or stack. So the process is a long process. The process is long. In multithreading, we create subcomponents, or we divide the process into multiple components. Like there's a P1 process. There are P1 process having some 4 or 5 components, and each component have their size, fixed or dynamic size. And the same, there is a P2 process having same data section. But in some process, if there are 2 processes having some common data, means the process 1 and process 2, there is some common data which the P1 is also accessing and P2 will also access. So in multithreading we create only one data section in which all the codes are having P1 data section code and code section, and P2 code section also available, and the one data section, one code section, and one file section. So there are single code section, data section, file section, and we create a some single or small process or lightweight process called threading. These small processes having their thread ID, register ID, and all things. They don't have their data section and data section, code section, and file section, because these threads, these lightweight threads, access the data and the code from the common shared section. Like here there is a process P1 and the process P2. Okay, in process P1 it is a single threaded process, and in multi-threaded it is a multi-threaded process. Whatever, in single threaded process there is a process having the code section, data section, and file section, register and stack section, and there is one single process. There is only one single process accessing all these sections. But in case of multi-thread, there is a code section, data section, file section, which are common for all 3 threads. Okay, and one single thread have its own register and stack. Register and stacks are individual for each threads, but the codes, data and file section which are large in size, there is a large code size, data size are common for all threads. Means all these threads can access the data and the code and files from common shared section. Here the shared among threads, code section shared होता है, data, OS, resources and open files and single or heaps. These are things which are shared between the threads, Okay. Unique क्या है? Each threads have its thread ID, register set, stacks and program counter. These are each for each threads, but these sections are only one for all process. Means common shared. And advantage of that. What is the advantage of multi-threading? Advantage is that it is a responsiveness because of its lightweight nature. If there is a multiple thread T1, T2, T3 and in multiple thread there is a multiple process, and if a single process we create a multiple threads, so due to the process become fast, so multiple threads can run in a limit time because of lightweight context faster. Because of lightweight nature, context switching become faster, resource sharing और economically सस्ता पड़ जाता है, because it required less memory than non-threaded, because in threading there is a common shared, not need to be each process having their data section, code section and file section, other sections. Here only common code section, so the less resources will use. Faster context switching because of its lightweight process, and responsiveness is because we create a multiple lightweight threads and it become faster. That's why it become fast response to the users. Okay, so type of threads, there are two types of thread: user level thread and kernel level thread. In user level thread, what happens? In user level threads, user process is multi-threaded. Means that process which are created by users are multi-threaded, divided into multiple small components or lightweight process. But the key point is that this threaded, if the user level process are threaded, then this is done by the CPU, but don't know about the OS. This is the CPU divided the user level process into multiple threads, but here the OS don't know about that. User no OS है, OS don't know about the process is having multiple threads. It happens only in user level threads. In user level threads, process is divided into multiple threads, but OS don't know about that. Right? Kernel level threads. In kernel level, the OS process is multi-threaded. जो OS की प्रोसेसेस होती हैं उनको multi-thread किया जाता है in kernel level threads, and OS know about that. Okay, so user threads and kernel threads. User threads, multi-threading in user process, multi-threading kernel process. Kernel threads is create become a multi-thread the kernel process, and here multi-thread the user process. Created without kernel intervention. Here the involvement of operating system is negligible or zero. Here the involvement of OS is required. Kernel itself are multi-threaded. Okay, context switching is very fast. Here the context switching fast context switching is slow. If one threaded is a blocked, OS block entire process. Here, if the process having multiple threads and if one thread goes in input output state or any block state, then the OS will block the entire process because the OS don't know about that. The OS didn't know that the process is multi-threaded. If the OS says that the process is in block state, the process block entire process because he don't know about his process is in multi-threading. In kernel threading, individual threads can be blocked. Generally can run on any process, any OS. This user process multithreading can run any OS and it is specific to OS. Faster and create manage, slower to create and manage. Here the system calls programmatically way in which computer program requires a service from kernel. If we want to the OS interact with kernel, system calls we request to a kernel means that in system calls we create a request. We create a request for the kernel to the kernel for doing something system. Here's the flow. What happened? We create a request process from user space. We create a request, interrupt request for kernel and control transfer to the kernel. Means that as you know, there is a two modes, kernel mode and user mode. In user mode, if we are using system, we are in user mode, and if we create a request, then the OS change the mode from control user mode to kernel mode and execute the function of code. Then it again convert the mode from kernel mode to user mode. The fork and system call. Fork system call is used to creating a new process which is called a child process. In a fork call, what happens? Like here the process P1 having the code and after executing some line of code starting, here we call fork process, we call the fork function. In fork function, what happens? In fork function, it create another copy of that code and execute them from where it is called. Like here the fork is called, and after that it create another copy of that code from where it called. Like so after that means that after fork section it create another copy of that code and execute. So this process is called, this section is called child process, or this is a main process. What it's a return value of the fork. So the fork take no parameter and return integer value. Fork function can't take any parameter, but it's return integer value. If there is a negative value, the creation of a child process was unsuccessful. If the fork give a negative return value, then it is a unsuccessful creation of the fork process. If it gives a 0 return, then the newly created child process. Fork return 0 to the newly created process. And the positive value when the fork created successfully, it return positive value return to the parent or caller the value of contain post process ID newly created child process key. Okay, here we take example to understand that. Here the void main function, the integer x, and there is a fork function. Then when here after that fork function execute, what happened? There are two cases occurs. Here parent process and another similar process will create here, which is a child process. So the parent process, when fork called, it return what? Any positive value which is a child ID. It is a child function's ID. It return child function ID. If the fork creates successfully, then x become 1, 2, 3, 4. Okay, and it return x, print the x value, and after executing this function, it create a child function, child process, the child process will execute from here also. Child process execute the code from here means child, there is a process which is start from here. So in child process it return 0. In child process it return 0. So x become 0 and the print 0. Okay, here's the same example. Void main had a fork. Here the fork is created, and there's parent, then fork is created, then p and c1. After that, here the fork function, fork execute, divide the process in two parts, parent and child. Then after that, if there is a two process, then each process having the fork. So after that p process, it will again execute two process, fork process and child process. And here C having same code base after in fork, and this fork create another two process, child and child one. Means if it is a parent, then it is a parent, or it is a child. If this is a parent, then it is a child, childs of child process and childs of child process. Okay, now the wait system calls. In wait system call, a call to wait a block of calling process until one of child's process complete. In this, what happens? If the wait system calls happens, then it block the parent process or stop the parent process until the child process is completed. First complete the child process, then after that parent process will execute. Thank you. You can get the PDF in my Telegram channel, link in description.